All right, hello everybody, and welcome to lecture 3 of 9 lectures. I am Dr. Kelechi Uzachukwu, and we are today going to talk about contingency tables. We're essentially introducing these variables that we talked about in lecture 1 and 2. We're going to introduce them with other variables now, and we're going to talk about them in terms of a relationship. So lecture 2 is all about finding relationships through contingency tables. So, didn't think you were going to get into relationships in a stats class, but we are very much going to be talking about relationships. And so relationship 101, a person's attitude or belief about a particular public policy or issue is contingent upon their other beliefs and life experiences. So, for example, abortion policy has been presented as a feminist issue, religious issue, and an ideological issue. What does that mean? A researcher would therefore want to include these specific variables in their study of abortion opinions. So if it's a feminist issue, well, let's see if men and women think the same way. So we would include the variable gender. What about religion? Is that an issue? Well, then we would include the different religions in our data set, and we would call that variable religion, right? Political party, political ideology, we could look at that in terms of actual political party or in terms of whether you are conservative, moderate, liberal, right? And we know those two variables are different types of variables because we learned that in lecture 1, okay? So political party is a nominal categorical variable. Political ideology has some order to it, right? Moderate can't be on either ends of the extreme. It has to always be moderate in the middle, but I digress. All of these variables could possibly affect one's attitudes on whether women should have the freedom to choose an abortion for any reason. Okay, so these reasons, these guesses about what we think might happen between men and women or between political parties or religion, these are hypotheses. These are educated guesses that are based on past experiences, past research that we've seen about maybe something else, right? But these are variables. These are guesses, about relationships between these two variables. And we'll talk more about hypotheses in lecture 5, I believe, but it's a quick and dirty introduction. So the researcher could argue that one or more of these reasons, the independent variable, influences one's beliefs about abortion, the dependent variable. So the independent variable is essentially the cause, what we think might be causing the dependent variable to change, to affect what we think might be affecting that, the change that we see, right? So because repetition is good, here it is again. The independent variable is the cause of what we're looking for in the dependent variable. So the dependent variable, the main variable, is always our dependent variable, the main variable of question, right? Variables are questions. So the main question we're asking in our study here is, what causes people's opinions about abortion to fluctuate? Or are men and women, do they think differently about abortion opinions, right? So, so the independent variable is the cause, what we think might be causing the dependent variable. Okay, and so the differences or changes in an independent variable lead to differences or changes in the dependent variable. I'm saying the exact same thing, but maybe one of these sentences will click, because you can say one thing many different ways and it finally clicks for someone. So when two variables are related, observations with different values on the first variable, the independent variable, tend to have different values on the second variable as well. What does that mean? Let's give an example. If gender and abortion attitudes are related, then one sex will be more likely than the other to support pro-life. Let me say it a different way. When we have these two variables, if they are related, what we see among men is going to be, as you see here, different among women. It's going to be different, okay? Their thoughts about abortion specifically, it's going to be different. Okay, so the next line asks you to give an example for yourself of a different relationship. What about political party and universal health care? I'm going to give you a second here. I'm going to give you a second. Okay. Hope you like my glasses. Okay, so an example here of the relationship, or a hypothesis of the relationship between these two variables, might be that one political party would favor or oppose universal health care over another political party. Specifically, we could say maybe Democrats favor universal health care more than Republicans, right? Or libertarians, or whatever. We could say something like that. One way, to test whether relationships exist between categorical variables is to run separate frequency distributions for each value of the independent variable. Okay? Remember in lecture 1 that we had two types of categorical variables. Both of them we'll look at here because they're categorical variables, and what we'll be looking at are categorical variables, whether they're nominal or ordinal. Okay, so here we have a table. Hopefully we remember that it's called a frequency table. And in a frequency table, we have how many variables? Just one variable. And we see above in table 1A that the variable here is, here it is, abortion if woman wants for any reason. So the question asks, why do you, do you approve or oppose abortion for any reason? And what are our responses? Our values are here, yes, no, and then we've got some missing values because someone said I don't know, someone says no, had no answer, and then we had some system errors. We're pros at this already, so we're not going to go through that missing stuff. But what I want you to see here is what's circled for each frequency table. In the top, we've got only men. So we had an entire data set of about 1,000 people, right? 431 of those people were men. 569 were women. And we decided to split that data up because we wanted to understand what might be happening here with men, what might be happening here with women. Okay, so that is the logic here. Okay, and so for that reason, we took two different data sets. We took one data set and split it up. Said, hey, you go one room, males. Hey, you go in another room, females. And then we're going to survey you. And you're going to say, yes, I have favor, or no, I don't favor. Okay? We could do this all day. We could have multiple frequency tables. Say, for example, the question is, what's your opinion about abortion if you are based on political ideology, right? How many frequency tables would we have here now? Well, if political ideology is broken up into liberal, moderate, and conservative, we have 3 values. Just like we have 3 values, the 2 values here, we have 3 values for political ideology. We would have 3 frequency tables. What if we said very liberal, then liberal, moderate, conservative, very moderate? That's 5 values. Now we would therefore have 5 frequency tables. Probably not the best use of your time, my time, the viewer's time to see all of these tables parsed out that way. Granted, it is informative, but we can do this a better way because you know what? Relationships are complicated. We're not going to make it more complicated by having one table split up into all these extra tables. It's complicated, folks. Let's make it as simple as possible. So what do? First off, let's remember frequency tables and charts help us simplify data, right? We were able to see that in the past slide, but then we broke up that data and almost unsimplified ourselves a little bit. So contingency tables takes frequency tables to a whole nother level. Okay, we're graduating. We're going from understanding ourselves as one variable to understanding ourselves and somebody else, two variables, okay? And we cannot have a relationship with, well, we could have a relationship with ourselves, but in order to understand the relationship that we have with someone else, we need to engage a contingency table because relationships are complicated, folks. So when we are trying to understand them, contingency tables help us further simplify the data. And it even provides us even more data, okay, than what we're able to see in only a frequency table with one variable. So here we have a contingency table, folks. Welcome to a relationship. Okay, so we see to the left our dependent variable. This is going to be our rule of thumb to always put our dependent variable, our important question, on the left. And then the question that we think might affect that question, our independent variable, we're going to always put it on the right. And so here we go. Our dependent variable is called opinion on abortion. The three values for that variable: pro-life, which means no, don't support abortion, depends, kind of on the fence. Pro-choice means I absolutely support abortion, okay? And so we see the values here, and then we see the variable political ideology, and there are three categories there, okay? And so our categories are conservative, moderate, liberal, okay? And then at the end of each row and column, we have our totals. All right, so notice one thing. Are these absolute frequencies or relative frequencies? Hopefully, you're immediately saying absolute frequencies because these are not percentages, right? Relative frequency is relative to something. Absolute frequency means this is the absolute number. It's not correlated or it's not related to some other number. It is just 2,118 people who are conservatives are also pro-life, right? So if I ask you how many people are pro-life and liberal, hopefully your answer is 163, right? So this table is as basic and as simple as they come. How many people said that they're moderates? 2401 should be your answer there, 2401. And those who said I'm pro-choice, hopefully you went here and you see 2,365 people said that they are pro-choice. Now that we understand how this contingency table works, we have one table that we might have had to do 3 times, 3 different tables. But now, because we want to simplify relationships, because they are automatically off the cuff complicated, we want to make it as simple as possible. Boom, we provide one table. Thank God for contingency tables. Okay, and so another thing we need to know is that these are absolute frequencies, but at the end of each column, at the end of each row, columns going up and down vertically, rows going left to right horizontally, right? So at the end of each column, we see what's happening in that entire column. At the end of each row, we see what's happening in that entire row, right? And that's where we see our totals. And then the total for everybody who said that and who answered this question, both questions to be exact, is 8,761. 8,761 people answered, had answered political ideology and abortion. Now, this is important to note that 8,761 people answered both of those questions. Remember missing values? Contingency tables are not concerned with missing values. Why? Because we're trying to simplify relationships. So we're not going to start calling out all the things that are wrong with so-and-so. We're not going to do that. Not in a relationship. We're going to edify, we're going to encourage, and we're only going to focus on the things that we both agree on. The things that we both agree on. So maybe there were more than 2,716 people who said they're pro-life, but they didn't answer the political ideology question, or it was missing, or there was a system error, something happened. But those who answered their abortion question and the political ideology questions are the only things we see here. So if it's missing, we're not dealing with it, because all we care about is what happened here, and how do they connect. Okay, so let me stop beating that horse and move on. So here we go. Contingency tables, we first looked at the absolute frequency. Now we're going to look at the relative frequencies. As you can see here, the relative frequency we're looking at is the row percentage. And yes, you've probably guessed it. It's the percentage at the end relative to the row, So in this row, we've got only pro-life folks. You with me? In this row, we have only pro-life people. So that means the 2,716 people. Of that number, the number of people who said that they're conservative, 2,118. 2,118 people, you divide that by the total number of people who are in the pro-life room, right? We told everybody, hey, if you're pro-life, you go in this room. Depends, you go in that room. And pro-choice, you go into this other room, okay? So now we've got 3 rooms. If we're looking at rows, we have 3 rooms. A room filled with 2,716 people, a room filled with 3,680, a room filled with 2,365 people. Now, in those rooms, again, say we go into the pro-life room, we say, please raise your hand if you're conservative. Okay, 2,118 people raise their hands. That is a total of 78%. We see that here in the calculation I provide. So 78% of those in that room are conservative. I underline this not just for aesthetic purposes, but because this is really important. After the word of, the next word that has to come after the word of, absolutely has to come after the word of, is that room. So if we're talking about the room of people who said no, then we are talking, then we need to say that right after the word of. And then we say are conservative. I'll give you another example. Well, said another way, 78% of pro-life respondents are conservative. We're saying the same thing. 78% of respondents who said no are conservative. Notice after the word of, we're still saying what's happening at the end of that row, at the end of that row, okay? Let's try another one. So what percent of respondents who said yes are conservative? So if we remember that we're dealing with row percentages, at the end of after the word of, what percentage of, and it's telling us what room we need to go into. The room we need to go into is the room with everyone who's pro-choice, the room with everyone who said yes. Okay? So that room has how many people? Absolute frequency of 2,365. 2,365 people said yes, pro-choice. Okay? And so of those that number of people in the room, how many people are conservatives? 733, right? We can see it here, 733. So we'll calculate that. 733 divided by 2365 should give us our 31%. Here we go, 31%. Just like 2118 divided by the end of that row gave us 78. 733 divided by the end of that row gave us our 31. I wonder what gave us our 56 then. 2061 divided by 3680 should give us our 56% of what? Of people who said, depends, maybe, I don't know. Of those people, 56% of them are conservatives. Okay, we've got one more example here. What percent of responded to, oh, I just did that one. Wait, hold on. Oh, I didn't, it's moderate. Sorry. What percentage of responded to said maybe are moderate? So we go to the maybe room. The maybe room, 3680. 3,680 of them are moderates. And, of them are maybes. And then of the people in there who are moderates, 1,067. Okay? 1,067 divided by that 3680 should give us 29%. Okay? 29%. Here we have it. So we should be able to go here and say what exactly this percentage is, right? If we're talking row percentages, this percent means 6% of those who are pro-life, 6% of those who are pro-life are also liberal. Okay? Last thing to note here, at the end of each row, you see 100%, right? And so that should always be seen if we're looking at row percentages. If we've calculated row percentages, these numbers across the row should all equal 100. 78 plus 16 plus 6 should definitely give us 100. 56, 29, 15 should give us 100. 31, 38, 31 again, give us 100. What will not give us 100 is going down, because these are row percentages. So going down doesn't give us 100. And we see that because 78 plus 56 plus 31 is not 100. It's a lot more than 100. Okay? So row percentages, you know that you've gotten the right percentages if across it gives you 100. Okay? So now, again, we've got our contingency table, and we are looking to have positive, encouraging, healthy relationships. Therefore, we are using contingency tables. We want it to maintain its health, and therefore we make sure that our dependent variable stays here on the left. We want to make sure that our independent variable stays here on the right. Okay? And now we've got column percentages. We've got column percentages. So first thing you want to notice is the last thing that I pointed out in the last slide. Okay, across, does it equal 100? No, 43 plus about 20, that's about 63, 73. So that definitely doesn't equal 100 going across. But going down, it does. Going down here, it does, and going down here, it does. So going down is what column percentages are all about. So we know that from the row percentages that we're talking about the dependent variables being in different rooms. Now we're talking about the independent variables being in different rooms. So the independent variable, there's a room for conservatives, for moderates, for liberals. Okay, so in that room of conservatives, how many people are in there? 4912. That's how many people are in the room of conservatives. Okay, and then we say, please raise your hand if you're pro-life. What happened? 2,118 people raised their hands. Okay, we can see in this equation, 2,118 people raised their hand in a room full of conservatives at 4912. So 43% of conservatives are pro-life. I'm going to say it again because before we said the percentage of pro-lifers who are conservative. Now we're saying the percentage of conservatives who are pro-life. So the percentage of the people in this room is conservative. So the percentage of, after the word of, we say the room. Remember that. So the percentage of this room who are pro-life, 43. The percentage of this room, the moderate room, who are pro-life, 18. How do we get that 18? 435 divided by 2401. Hopefully we can see that. So 18% of that room of moderates said, yep, me, pro-life. Okay? Let's do some more examples. So what percentage of the conservative respondents are pro-choice? So first off, we're going to what room? Because the word of tells us what room we're going to. After the word of, I see conservative. So I'm going to the room of conservatives. Then I say, hey, raise your hand if you're pro-choice. How many people raise their hand? 733 people raise their hand in that room of 4,912. Okay, 15%. Now, what about what percentage of moderate respondents are unsure? So if we're wondering what percentage of moderates, well, first let's go to the moderate room, okay? The room is filled with 2,401 people. We say raise your hand if you're unsure. Shoot, more than almost half of them raise their hand. To be exact, 1,067 people raise their hand, so that's about 44%. I feel like you're getting the hang of this. I hope I'm right. Okay, so we've talked about row. First, we've talked about absolute frequencies, these numbers, right? Then we've talked about relative frequencies in terms of rows, right? At the end of the row, that's what we're concerned about. What's happening in the row rooms, Now we looked at column percentages, what's happening in the column rooms, okay? What do you think we're going to do next? Well, we're going to look at total percentages, what's happening overall. Like we tell everybody, come back in to the plenary session, come back into the main conference, everybody come back, let's have lunch, let's talk. Okay, so how many people come back in the room? 8,761 people come back into that room. Okay, and then how many of those people said they're pro-life and conservative? Pro-life and conservative, we already know, is 2,118. But now we're not in a room of 2,700 or a room of 4,900. We're in the whole doggone room where everybody is there. And now the researcher, is saying, hey, raise your hand if you're pro-life conservative. 2,118 people raise their hands, and we have to divide that by the total. So of all of the respondents, how many of all of, remember the word of, after that we talk about the room. So this room now, this total percentages room, looks at everybody. So anything in this room is being divided by this, not by any column or row, column percentages or row percentages. No, this is the total. So the 24.2% of the people in the room, the entire room, right, are pro-life conservatives, 24%. What percent are pro-life? Well, let's go to the entire room. Let's ask all the people who are pro-life to raise their hand. Pro-life, where is it? Right here. It's at the end of the first row. So 2,716 people raised their hand in that full auditorium of 8,700 plus people. And we've got a percentage of 31% of those in that room are pro-life. Okay? The percent who are conservative, then we go to the column percentage because that's where conservatives are. They're in the columns, right? So the conservatives 4912 divided by our total, that gives us our total number of people, percentage of people in that room, in that entire conference who said, yep, me, I'm conservative. So here we see it in the table, 56.1. So one thing I want you to notice about this total percentage table is that all of these numbers in this box add up to be 100. So if you remember in the row percentages, what added up to be 100? The things across the row would add up to be 100. In the column, the things going down would all add up to be 100. But now in the total percentage, 24.2 plus 23.5 plus 8.4 plus 5.0, all of this should add up to be 100, okay? And even if you add this across, it'll give you 31, but when you add this and then the 42 and the 27, that will give you 100. And if you add the columns up, that should give you these numbers you see here, but when you add those all up, that should also give you 100. So about 60 here, about 30 here, and then about 10, 20 here, okay? That should give you 100. So let's do a little bit more practice. What percentage of the total respondents are pro-choice? The pro-choice, well, first off, we know this is the entire room. We're just asking everyone who's pro-choice to raise their hand. How many people raised their hands? Well, 2,365 people raised their hands. So we've got about 27%. We can see it here, are pro-choice. And then of the entire sample, how many people are unsure liberals? First off, again, we're looking at the entire room. We're saying, hey, if you're unsure about this question about abortion and you're a liberal, only then should you raise your hand, okay? Not unsure and conservative, not unsure and anything else, just if you're liberal and you're unsure, please raise your hand. Who raised their hands? 552 people out of that entire room. So one thing that you need to know about total percentages is that they are one way that people can manipulate data. With column percentages, we can go to a room, right? And we can see of the people who identify as this or that or the other, how many of them think this, that, and the other, right? Whether it's a column room or row room, but what happens in a total percentage plenary session, everybody in there, what if, like in this scenario, we've got more than half of our people are conservatives, right? And so just like we saw in lecture 1 about how tables can be manipulated, how charts can be manipulated, total percentages is another way of manipulating this information. Because we can say, depending on the number of people that are maybe some surveyor has oversampled conservatives. In this case, that was definitely what we see. 4,900 people are sampled here who are conservatives. So that's gonna weigh in on these numbers that we see here. That's just gonna be much higher than any of these numbers even combined, right? 56 is much higher than these numbers combined in terms of liberal and moderate. So we don't want to focus on total percentages, but we do want to recognize that people might not know what they're doing or might know what they're doing and use those percentages to present information, to interpret information, and it will not be the right way to do so, unfortunately. But you're smarter than that now, and you can identify that when it happens. So, all right, we're pretty much almost done here because we've gone through the bulk of everything we need to know in terms of relationships, how frequency tables go to another level, and we look at them through contingency tables to improve our relationships and just focus on what's matters and what's most important. And now I like column percentages. Most people use column percentages because it allows us to see what's happening in the rooms of the independent variable. So if we create our table the correct way, say our column percentages should be our independent variable rooms. So in this case, our columns are the conservative room, the moderate room, the liberal room, okay? And so let's go to the conservative room. What trend are we seeing? First thing we should see is that a lot less people say pro-choice, okay? So people are really against abortion, right? In conservative room. Let's go to the liberal room. What's happening? People are more pro-choice, a lot more pro-choice than in that conservative room. But what are we seeing in the middle? And what are we seeing even in the middle across the rows, right? We see these numbers for conservative is so much, it's the conservative room, we see that they don't know or maybes are so close to the pro-life folks. And we see that the maybes for liberals are pretty close to the pro-choice folks. And then we see in the moderate group that there's just what's happening. It's going up, down, then, it's going, up, down, then up, right? Excuse me, it's going up and then down. It's just three. So it's going up and then down. So there's really no trend. It's like, what's happening? So here is an important rule. An important rule about contingency tables and about variables with categories in general is that we focus on the extremes. We do not, again I say, we do not focus on what's happening in the middle, because oftentimes in relationships we're concerned about we are often mostly concerned about what's happening at the extreme ends, because that's where we see major differences. Those that are moderate or those that don't know, it depends. It depends because they really don't know, right? And so we're concerned about people who have opinions. And so if that's the case, then we scratch out or ignore. We never really omit it, ever. We don't omit anything or leave out anything, but we just know that, wow, this is pro-life is so much higher than pro-choice for conservatives, and pro-life is so much lower than pro-choice for liberals. So we're focused on those extremes. Okay, and we don't really concern ourselves with what's happening in the middle, whether it's maybe or whether it's moderate. Just a rule of thumb. And so we're just looking at this table, contingency table. We're looking at it now using a frequency chart. Okay, we can see here that conservatives are in gray, moderates, we're gonna just bat a blind eye to it, and liberals in blue or cyan. Okay, and we can see that the conservatives are going like this, right? And they've got a whole different another shape than the liberals going in the other direction. So one thing that we want to notice, whether we're seeing it here in the table and we can see the up-down trends, or whether we're seeing it here in the frequency charts, what we want to note is that when, as I said, I believe it was slide 3 or so, I said that if one thing does something and another thing does something different, there lies our relationship. If conservatives and liberals thought the same way, then we would see the same trend here. We would see that we would see the same like shape here, right? Going in the same direction, and we're seeing them going in opposite directions. So this is a relationship. This is definitely a relationship. Just like here, they're going in opposite directions, right? So this is a relationship. When they're doing the same thing, probably not a relationship. We go from a line chart to a bar or column chart, right? And we can see the trend. We can see, let's see the gray. We see that it's going from high to low, and we see the blue is going from low to high. So again, we're seeing them doing opposite things. So we know that that's probably a cause. And we don't really say cause because there's a lot more statistical things that come with saying cause. So we just say that it's highly associated with the variable abortion, okay? So we don't say cause. Again, I say we do not talk about causality here. All right. One more example we've got here, gender and premarital sex opinion. So we see that for gender, that men think it's always wrong a lot more than they think it's not wrong. And we see for females that it's always wrong a lot more than it's not wrong. So what are we seeing in the two trends? We're seeing that they're similar. They're actually doing the same thing. They're going, one is going up, the other is going up. Not doing that opposite thing. They're in a positive relationship. And we'll actually talk about that in lecture 4, whether a relationship is positive or negative. But these are actually this is actually a positive relationship because we're going in the same direction. What happens in a relationship where things are not going well? You're not seeing eye to eye. You're going in different directions, right? So when you see things going in the same direction, positive, even if it's going down, it's still going in the same. I'm going down, you're coming down with me, then that's like a positive, like ride or die. so it's still a positive relationship, okay, regardless of it, the fact that it's going down together. Together is the main point. All right, so here is our gender and premarital sex opinions relationship here again from a table to a chart, and we can see that they're pretty much doing the same thing. They're not crossing like opposite the way the other one was. They're going relatively in the same direction. It's not identical, but we're not asking for it to be identical. We're just wanting to see, are they sort of thinking the same way? And it looks like they are. Men and women think that it's always wrong, more so than they think it's not wrong. Okay? And here's a third one. So we've got females going from low to high, males going from low to high again. So however you look at it, it should always tell you the exact same thing. So when visualizing frequency tables, what we want to do is use relative frequencies rather than absolute frequencies. Again, we talked about this maybe in lecture 1. Yes, frequency charts, where we looked at all those different types of charts and tables. And so we want to use relative frequencies for the reason why we say we use column and row and not total. Okay, so if we're using relative frequencies, we know that it has to equal 100%. Right? So it has to equal 100% because we're talking percentages. And so focus on how similar or different the lines are to each other. No relationship equals each of the lines are very similar. Identical is somewhat extreme, but very similar, like what we saw already with gender and premarital sex opinion, right? It was similar, wasn't identical. And then with the strong relationship, we see that there are big differences, just like we saw with political ideology. Conservatives were going one way, liberals were going another, moderates we're not concerning ourselves with, not because they're not important, but because they skew the data, they confuse the data in our statistics. Okay, so just one final frequency chart for us to look at. Yes, it's a line chart. What's our two variables? Okay, first variable we're looking at is the main variable, premarital sex, right? That's our dependent variable, and we're saying, I wonder what might cause this to change. What might, and again, the word cause we're using very loosely because we're not doing that, we're not doing experiments and hardcore statistics yet. And we won't in this course, to be honest, but and then the second variable, political ideology, political views, liberal, moderate, conservatives. And we have 4 values for our premarital sex opinion: the always wrong, almost always wrong, so on, right? And so I'm curious, what do you think the relationship is here? Is there a relationship? Is it strong? Is it medium? Is it weak? No relationship? What do you think based on everything we've talked about so far? Well, this contingency table, this frequency chart that came from a contingency table is probably, in my opinion, either very weak or moderate. And I say that because they're sort of going in the same direction, right? We can see, I would say maybe moderate, not even weak, but moderate. If we're looking at liberal and conservative, meaning we're looking at red and blue, we can see that they kind of have this V thing going on. Liberals have conservatives have pretty much 3 points, 1, 2, 3. Conservatives really do have a 4th point, and so RV ends up being sort of, but it's going in the same direction. So that's the first thought I have, is that they're going in the same direction, so the relationship can't be that strong. If it was strong, where the conservative is a V, the liberal, I would say, which should be an N, or upside down V, right? That's what I would call a strong relationship. But in this case, we're seeing that they sort of think the same way. Okay, so maybe not no relationship, but a very weak one. All right, so that is it, and we're going to do a quick summary here. Relationships are complicated, trust me, I know. And so we use contingency tables to help simplify these crazy relationships that we get ourselves into. Finding relationships among variables is arguably the most important task in data analysis, hands down. Okay, and so says my battery's gonna die. And so let me hurry up and talk. If the percentages are not practically identical, there is a relationship. And the more the row or column percentages differ, the stronger the relationship is. Okay, and why do I say row column and not total? Because total does not take into account what's happening in those specific rooms, okay? And you might have a lot more people in one room than another, so you have to take those rooms into account. And do not solely look at one category, and when you do look at the categories, look at the 2 extremes. Don't look at the stuff in the middle. All right, thank you so much. Hope you enjoyed the lecture. Bye-bye.